As Nell mentioned, my name is Isabel. I'm a software engineer at MongoDB, and today I'm going to be walking through the process of implementing a language-agnostic specification in Rust. So we'll start off with a bit of background info. A database driver is a library for users to interact with their data. So the driver exposes idiomatic APIs, and then under the hood, it communicates with the user's database cluster by issuing database commands. So it's kind of acting like a middle layer between a user and their data. So the entry point for the driver is a client, and this is what the user creates to connect to their database cluster. A cluster can contain many databases. Each of these databases can contain many collections, and the collections are where the data actually lives. So data in MongoDB comes in the form of documents. Documents are a flexible data type. They contain key value pairs. They kind of look like JSON. Data in collections is not required to conform to any kind of schema, but one thing that every document does have is a unique identifier, and that's that top _ID field that you see right there. So I mentioned that I work on the Rust driver, but MongoDB has drivers in all of the languages that you see here. And all of these drivers conform to a common specification, and this spec defines the general API that each driver should expose. And this makes sure that all of our users have a consistent experience as they write applications in different programming languages. Makes it easy to move back and forth. Now I want to call out this sentence from our specifications repo. It says, drivers should strive to be as idiomatic as possible while meeting the specification and staying true to the original intent. So as we design our API today, we really want to think about striking a balance between following the intentions of the spec, but also designing in a way that makes sense for Rust. All right, so let's get into the topic for today, which is the new BulkRight API. So our task is to add a new API for using this BulkRight database command. Now there are three major types of write operations that you can perform on your data. That's inserts, updates, and deletes. So BulkRight executes a list of these different write operations. You can execute many, many different writes just in one shot. BulkRight can also write to data across multiple databases and collections. So using this command can be a really big performance improvement because all of your writes are sent in one round-trip message between the driver and the database cluster rather than a bunch of different write commands. So we're going to use this driver specification as our frame of reference for designing this API. Now this looks kind of like Java-esque pseudocode, but the idea here is that every single driver should have a BulkWrite method that allows users to perform a list of mixed write operations. So let's look at some of the more fine details here. So first off, method is exposed on the client type because we're writing across multiple databases and collections. The BulkWrite method accepts a list of write models, and these define the writes that should be performed as part of the BulkWrite. It also accepts options to configure the behavior of the BulkWrite. And upon success, it will return details about the writes that were performed. So we'll start off our Rust implementation just by stubbing out a method definition. This isn't too different from the spec, but I'll point out a few things to be aware of. So first is that this is an async method, and that's because we need to perform I/O to communicate with the database cluster. And secondly, we're returning a result enum here to cover any possible errors that may occur. So it stores the BulkWrite result and a MongoDB error. We're not going to get into the details of the error API today, but we're still going to represent this in our method signature. All right, so our impulse now is probably to define all the types in the signature and get on to what might be the fun part, which is implementing the BulkWrite functionality. But before we do that, I want to set a user example. And this is going to help us test the usability of our design as we go. And this is a really, really important step in designing a new API. So we'll define a couple of databases. First off, I have a database containing all of my to-do lists, and in that I have a collection with my grocery list. Documents here you see on the right, very simple, just a name field with the name of the item that I need to buy. And I also have a database with all of the food in my kitchen, including a collection of all the vegetables in my fridge. So again, really simple documents, just the name of the vegetables, the date that I purchased it. Might be using this to figure out which of my recipes I have the ingredients for. And I'm writing a Rust application that will update these collections when I go grocery shopping. So the idea is that I can call this method to delete a vegetable from my grocery list and insert it into my food database. So this is the code example that we'll be referencing as we start to build up our BulkRight API. So we'll kick things off with the write models, the first input to BulkRight. So the specification defines the write model type as an empty interface. And there are a number of more specific write model types that implement this interface for all of the writes that we can do in a BulkRight. Now, when we see interface here, we might think to implement write model as a trait in Rust. It's kind of the equivalent type. But the spec also permits using an enum for the write model type. So we're going to choose to do that instead. And that's because enums are generally a more natural way to represent mixed types like this in Rust. If we were to use a trait, we might need to get some pointer types involved. Not going to be fun. So we'll define a write model enum, and we'll add variants for each of our write model types. And these will wrap each of these, or each of those more specific write models. So here's the spec definition for the insert one model. So for inserting a single document, has two fields. First is the namespace. This is the name of the database and collection where the write should occur. Now remember, we can mix writes across namespaces, so we need to specify that for each write. And it also has the document to insert. And we'll translate this into Rust. Pretty simple. Class becomes a struct. Now we've reached the first kind of sticky point between the spec and the driver API, which is this document type that I'm using in the insert one model. So documents can be really great for modeling flexible data, and they make a lot of sense to use in some programming languages. But often in Rust, or just generally, users are following some kind of schema for their data, and they want to model that with a native data type. So for example, documents in our vegetables collection, they have a name and a date purchased field. So I'd like to be able to represent this data with a struct, like you see on the right, and use this in my application. Now, this is the signature for the regular insert one method. And you'll notice that we're not actually using the document type anywhere. Instead, our collection type has a generic type T, and this models the type of the data in the database. So T can be document if you're working with flexible data, but it can also be something more strictly defined. Now we define the insert one method for all T's that implement the Saturday serialize trait. And this just means that the driver will be able to serialize the input into a document under the hood when a user calls insert one. So if I'm a user who wants to migrate to the BulkRight API, I'd really like to be able to work with my native data types in a similar way to this insert one API. So first thought, maybe we can add a generic type to the insert one model. So something like this, the document field can be any type that implements the serialize trait. And this is a great idea, but it has a few unintended consequences. So first off, the enum that we use for write models is going to need to have this generic as well. And we'll need to specify a generic type anytime we construct any variant. So this will make sense when we're constructing an insert one model, right? The T represents the type that we're inserting, but it doesn't really make sense for any of the other variants where we're not serializing any type of data. If we're just deleting a document, we're passing in a filter. The other issue here is that we're accepting a vector of write models in the BulkRight method. And so if we had this generic here, it would require that all of the models passed into BulkRight would share the same type for T. This would make it impossible to insert different data types into different collections. And this kind of defeats one of the main benefits of this BulkRight API, to mix all of our different writes. So this generic type just really isn't going to work for us. Instead, we're going to go back to the collection type, where this generic came from in the first place. And we're going to implement a method on collection to construct an insert one model. And this looks really similar to the insert one method. So remember, insert one model has two fields. First is the namespace. Collection knows its own namespace, so it can set that field, easy. The second is the document, and collection also knows its own type, so it can just serialize the given value into a document. And because we're handling serialization at this step, we don't need to worry about generics in our write model type anymore. So let's construct an insert one model in our user example. First off, we'll need to get a handle to our collection with the generic type configured, like you see here. We will construct a vegetable struct with the input to be inserted into the collection. Now remember that we need to implement serialize for any type that we want to insert, so we'll just derive that trait. And we'll use the insert1model method to construct the right model. So this is great. We were able to stick to the specs design for this right model type, but we still provided some utility for working with types in a Rust-friendly way. So our design takeaway here is to provide continuity with existing API. This is going to make your library feel much more cohesive, and it'll also provide familiar patterns as users explore new features that you release. Now, the details for the delete right model are a little less interesting, so we're just going to put in a comment for that and move on. So next up, we need to design the options. So the spec defines the BulkRight options as a class with a number of optional fields. There are quite a few options listed in the spec, but we're going to focus on the most interesting one, which is this verbose results option. So this determines whether detailed individual results should be returned for each write that was performed. If it's not set to true, only high-level summary results will be returned. So why make this configurable? It takes some additional time and memory for both the database and the driver to track the more detailed results. They're definitely going to be relevant for some users, but we're going to make all this extra work opt-in. So we translate this class into a struct, very straightforward. We'll have a public field for each option, and we'll derive the typed builder trait. And this provides a way for users to construct this type. So this is what it looks like to use typed builder. First, we call the builder method on the option struct. We call a setter method for each option that we want to set, which in this case is just verbose results. And then we build the struct. And then once we call BulkRight, we can just pass these options in. So this works. It's probably a familiar pattern to some of you. But it's also a decent amount of code that we needed to write just to set a single Boolean option. And we also had to construct an entire option struct just to set one field. Now, options are optional, and we try to provide good defaults that we think most users will rely on. So it's likely that most use cases look something like this, just setting one or two fields, or maybe even passing a none and not thinking about any options. So this option configuration design is what our driver API used in previous versions. But in the most recent major version release, we switched over to a Fluent API for options. And that was to reduce verbosity in cases like this. So let's take a look at how that works. So Fluent API starts off really similar, called the BulkRight method. But notice we're not passing in any options. Instead, we're going to chain a method call to an option setter method directly on the call to BulkRight. And then once we've set our options, which in our case is just one, we can call .await directly on this chain of calls to execute the operation. And the nice thing about this API is that I don't need to deal with any intermediary types to set an option. I'm just chaining on a method call. And if I'm not setting any options, I don't have to think about them at all. I don't need to pass in none anywhere. I just call .await right after calling BulkRight. So we'll need to revise our method signature in a few ways to transition to this Fluent style API. So first, probably most obvious, we're going to remove the options from the signature. So those are gone. Now, the comment in this method says that we're going to send a BulkRight command and return a response. But we can't really do any of that stuff until we know what the options are. Some of these options are sent in the BulkRight command. We also need to know whether we're going to return a verbose or summary result. So we can't really do any of this stuff anymore. We're just going to cross it all out. So what are we going to do in this method now? We're going to return this BulkRight action type. So this is what the action type looks like, and it kind of represents our BulkRight in limbo. So it has information about what should happen when the BulkRight is executed, but nothing actually happens when it's constructed. It's just holding on to information. So it's got the client on which we're executing the BulkRight, it's got the write models, and it has options. These are going to start off empty, but they'll be populated as the user calls option setter methods. And we'll expose these option setters on the action type. So for each option, we'll have a method that takes in a value and sets the internal option on the action type. So these setter methods are going to take ownership of the action, and then they'll return it back to the caller. And this is what makes it possible to chain these setter methods one after another. All right, so that's how this option setter method works. But how are we able to call .await here? Remember, the verbose results method returns back out the action type. So how are we possibly calling .await on a struct? And the answer is by implementing this into future trait. And this trait turns a type into a future that can be executed by calling .await. Now, the nitty-gritty details of how async and futures work are definitely beyond the scope of this talk. So I'm just going to highlight the two most important things to know about implementing this trait. So the first is that the body of the into_future method is what happens when .await is called on the type that implements it. And the second is that the output type should be the type that gets returned when .await is called. So let's put this into practice and implement this trait for BulkRight action. So we need to figure out what to fill in for these two question marks. And we can use the old signature for the BulkRight method as a reference. Remember, prior to switching over to the Fluent API, this method did all of the work for BulkRight. So this is what the into_future implementation should be doing now. So for the output type, we'll use a result enum with BulkRight result and MongoDB error. That's what BulkRight used to return. And for the body of into_future, which again is what should actually happen when .await is called on the action type, we will send the BulkRight command and parse the response. So this is now doing everything that BulkRight used to. So back to our user example, we've constructed our write models, we've defined our options API, and now we can actually call the BulkRight method. So first, we just need to put these write models into a vector. Great. We'll pass those into a call to the BulkRight method. And let's say we're interested in detailed results, so we'll set verbose results to true. And finally, we can call .await to execute the BulkRight and get back a BulkRight result. Now, this looks a little different from the specs API, but the idea is still the same. We're still allowing for option configuration. We're just doing it in a way that feels a little bit more ergonomic. So our design takeaway here is to make configuring or not configuring options simple. Remember, in the first design, we had a lot of overhead for setting an option. But with this Fluent-style API, users are only going to need to think about the individual options that they actually care about. All right, our last type that we need to design is the result type. This is the spec definition for the BulkRight result. It's just a class with a number of result fields. There's a lot going on here. Don't worry about reading everything. We can break these down into two result categories. So first is the summary results. And these are those summary counts tallied across all the writes performed for values like total number of documents inserted, deleted, things like that. These are always populated in the result. We also have the verbose results. And these are those individual write results we discussed earlier. They're only present if verbose results was set to true. So notice that these are defined as optional types. So we'll define a struct in Rust for this type with all of the fields from the spec. Now, what might actually be interesting here? So as we mentioned before, each document in a collection has a unique identifier. And we didn't set this value in the struct that we used to model our data. And that's totally fine. The driver is going to handle adding an ID if one is not present. And it reports these IDs in the insert1 results that get returned when verbose results is set to true. So as the last step in our user example, let's print out the unique identifier for the document that we inserted. So first, we'll get the map of individual insert results. Got to unwrap it, but that should be fine since we set verbose results to true. Individual results are mapped by their index in the list of write models, so we'll grab the insert result at index 0. We will grab the inserted ID from that result, and we'll print it out. So there's something in here that I don't love, and I'm guessing maybe others don't either. It's kind of a bummer that we need to unwrap something. So I can look at this, and I know it's going to succeed, but users generally prefer to avoid unwraps. And as a library developer, I don't want to create an API that requires something like this. So conceptually, we really have two different result types here. We have summary results and verbose results. And it's kind of awkward to represent them as a unified type. So my goal for this API is to have two separate result structs and return one or the other depending on what the user wants. So looking at this code, we can all agree that a verbose BulkRight result type should be returned, right? We set verbose results to true. But smart as the Rust compiler is, it can't quite make the same guarantee. And that's because we're configuring verbose results with a Boolean value. So it's obvious when it's set to true which type should be returned, but what if this were just a random Boolean value, right? This runtime configuration is preventing the compiler from being able to make the guarantees that we want. So let's take a step back and think about the use cases for this verbose results method. Now, we discussed earlier that it defaults to false. So the only reason a user would really ever call this method is to pass in true. Now, with that in mind, What if we just deleted the parameter? We could then assume that anytime this method gets called, the user wants verbose results. So we've gotten rid of our input. Great. Now we need to figure out a way to configure our result type in a way that the compiler will understand. And we're going to do this with generics. So you might think of generics as a way to define the type of a field in a struct, but generics can also be a really powerful tool to signal type information to the compiler. So first, we're going to add a generic type R to our BulkRight action type. And this is going to represent the type of result that should be returned. Now remember that the into future implementation on the action type defines what happens and what gets returned when .await is called. So now, instead of a single into future implementation, we're going to define two, because we have two different results. So when the BulkRight action is generic over summary BulkRight result, we're only going to track and return those summary results, and we'll reflect that in our return type. And ditto with the verbose BulkRight result. We'll only track the verbose results in this one and return a verbose BulkRight result. So we now need to add generics in all the places where we're using BulkRight action. So we'll start with the method signature. Remember, by default, we're only returning summary results. So we'll use summary BulkRight result here to signal to the compiler that, at least to start, we only want summary results. Back to the whole reason we added this generic. The verbose results method is where we're actually going to change the generic type configured on the action. And this method is implemented on BulkRight action of summary BulkRight result. And it's going to return back the same action, but with the generic type set to verbose BulkRight result instead. So this is like the old implementation, but instead of setting a Boolean, we're setting a generic. And by doing this, we're providing type information that the compiler can understand. Now you might be wondering why we're using generics instead of two completely separate types, and that's just so that we can keep all of the other methods generic over the result type. Other options don't care about this detail. So we'll take one final look at our user example and update it with our API changes. We've gotten rid of the parameter for verbose results, so we can delete that true value. And now when we .await the BulkRight action, it's going to return this verbose result instead, with non-optional result field. So insert results there is not an option. So our unwrap here can be deleted. So the changes made here are pretty subtle in the context of the code example, but this provides a lot of clarity in the API when it comes to the relationship between this option and the result. So our final design takeaway, provide the best possible type information. Having a really strong compiler like the Rust compiler guarantees that we can have this really good type information, and that creates a huge difference for your users. And that's it. Thank you so much for watching.